Nathan kept track of the amount of time, the number of pages he read each night. The table shows the direct variation. Or does the table show direct variation? If so, give the constant of variation, and if not, explain why. We have this chart, and in this chart we're asked if the numbers represent a direct variation. Here we have the number of minutes read, and here we have the pages read. We have 18 minutes and 6 pages. We have 30 minutes and 10 pages. We have 24 and 8. We have 45 and 15. In order to find if this is a direct variation, we look for a pattern to appear. I look at 18. How does 18 become 6? I divide it by 3. Let's look at 30. What happens when I divide that by 3? I get 10. When I divide 24 by 3, I get 8. And when I divide 45 by 3, I get 15. So the answer to this question is yes, this is a direct variation. And the constant of variation would be divide 3. But that's not a constant. Divide 3 is 1 over 3. This represents the constant of variation. Number 5. Use a unit multiplier to convert $15 per hour to dollars per minute. So, number 5 starts us off with $15 per hour. And we have to use the unit multiplier to convert the hours into minutes. The unit multiplier that we would use would be 1 hour equals 60 minutes. We would set that unit converter up because we want the hours to go away and we want the minutes to stay. Here, hour cancels hour, and I multiply going across. 15 times 1 is $15. 1 hour times 60 minutes is 60 minutes. And then I reduce 15 over 60 to 1 over 4 minutes. Converting this to money, 4 goes into 1. 2 times 25. So my answer would be 25 cents per minute. Let's look at number 6. Number 6, solve and graph on a number line. And we have the inequality x plus 4 is greater than or equal to 3. So how do we solve this inequality? We solve the inequality the same way we solve an equation. Split it at its inequality symbol, identify the variable, and we move the positive 4 with the opposite of positive 4, which is negative 4. What we do to one side, we have to do to the other. Negative 4 to both sides. We have x left over, which is greater than or equal to a negative 1. On my number line, we also had to graph this. I put 0 in the middle. Negative 1 is over here. Recognizing that this has an equal sign attached here, I draw a closed circle at negative 1. Remembering this symbol is going to eat the bigger number, I realize that this one over here is bigger, which is my variable. A number bigger than negative 1 is 0, 1, 3, 5, 100. All of the numbers to that side of the negative 1 are bigger than negative 1. Let's look at number 7. Number 7 says to graph the points 2, negative 1, and 4, 0. That's first. So, in order to graph it, we need an XY coordinate system. The first number tells us how far to run. The second number tells us how far to go up or to go down. Since the first number is a 2, I always start at the origin and I run 2 spaces. Then I look at the second number. The second number is a negative 1. So it tells me to run 2 spaces and then go down 1 space. And I put a point. The second point is 4, 0, which tells me to run 4, 1, 2, 3, 4, and do not go up or down. That's what the 0 represents. So you stop and put a point right there. That's step number 1. Step number 2 says to graph that line that connects those 2 points. And step number 3 said to write the equation that represents that graph. Well, in order to write the equation, I would need to know the y-intercept. The y-intercept of this line is a negative 2. So I have a y-intercept of negative 2, and then I also need to know the slope. The slope is going from this point to this point, or this point to this point. So let's say this point is point 1, and let's say this point is point 2. How do I get from point 1 to point 2? I go up 1 space, and then over 2 spaces. Remember, slope represents the rise over the run. The number that represents the rise is the 1. The number that represents the run is 2, which means my slope is 1/2. Putting it together, y equals 1/2 x minus 2. Remember, y equals mx plus b is the equation of a line in slope-intercept form.